The good lesson is getting a reasonable answer. You know, immediately you were wrong. Yeah. Yeah. 30 centimeters in 1 foot. I find that. There's 20 centimeters high. Well, then I don't know what that 4. And there's 26 tiles. So like 6 tiles for 1. And then you get the well, that'd be 6 by 6, wouldn't it? 6 tiles by 6 tiles. Oh yeah. So there'd be 36, and that would just cover the floor of it. That's about it, yep. We need how many square feet? How many square feet do we need covered? 76 square feet, right? And each tile is 400 square centimeters, right? All right. If we had 76 square feet and each tile was 2 square feet, if the units just match up, all I have to do is divide 76 by 2, right? And that would give me the number of tiles I need. Does that make sense? So we need to divide 76 square feet by 400 square centimeters. The problem is the units aren't the same, right? So the easiest way to do it is to convert units to change either this to square feet or that to square centimeters, either one. Square centimeters, the best way to do it is going to be to change it to square inches. We said there are 2.54 centimeters in 1 inch. So since it's square centimeters, we square it. That'll tell us square inches. We want square feet. How many square inches in 1 square foot? That would be square centimeters. It would be 12 squared, wouldn't it? So this would change it to the number of square feet we have. Somebody do that math real quick on the calculator. I believe it's less than that. 0.43 about. And then to get our answer, each tile is 0.43 square feet. I need to cover 76 square feet. Divide 76 by 0.43. As always, don't just type in 0.43 because it wasn't exactly 0.43, right? It's that A and S button on your calculator. 76 divided by A and S should give us about 177 tiles. About 177. Yeah, I think we heard right. I think 176. Oh, I thought you said 176. I don't know what I did wrong. I thought you did 36 big blocks at the bottom, and you know that these 4 by 5, 45. The bottom, and so you've got 4 by 5, right? Yeah. on the long six on this side. It should be more than 6 on this side. I thought about something right. You can get it that way also. Everybody good with how we did it up here? I think that's going to be the fastest way of doing it. Example 2. Example 2. Show that the equation below is conventionally correct. What's conventionally correct? Yeah, not that necessarily that it's actually true, but in order to have a true statement to begin with, we need the same units on both sides of the equal sign, right? Because the same units should be on each side. So force is measured in what? Newtons, which we said before, 1 Newton is equal to kilograms times meters per second squared, right? Times delta T, delta with the triangle mean, change in, time is measured in seconds. So on the left, we have, if I cancel seconds, notice here I have 1 on top and 2 on the bottom. This side I have kilograms times meters per second. What's that lowercase t again? Not pressure, that's capital T. Yeah, that's rho. It's supposed to have a T. There's lots of T's we use. That's density. Pascals are the SI units for pressure. Momentum, that's it. Momentum. What's the formula for momentum? Always being wise, you're using fluency, which might be working on momentum. Lowercase t. Momentum deals with motion. Mass times velocity. So on the other side here, mass times velocity. Mass is measured in kilograms. Velocity is measured in meters per second. Notice we have the same units on both sides, which means it's dimensionally correct. Right? Just because we have an equation that has the same dimensions on both sides doesn't necessarily mean that the formula is true. Notice I could say final velocity equals initial velocity. Well, they both have the same units, but if it's accelerating, that's not true. Right? Right. So just because the units match up on both sides doesn't mean the formula is true. But in order for the formula to be true, it has to be dimensionally correct. We have to have the same units. No. Go ahead and grab your books, put them open to section 1.9. You can, yeah. I'm not going to have an assigned feed chart right here, so once you move, we're on page 14. Page 14, let's spend about 5 minutes or so. I want you to read that section real quick on the graph. So the lab that we're going to start today, we're going to start dealing with graphs. On the AP test, in the free response, there's always one question that sets up a lab for you, and you need to kind of set up a graph and then go with that graph and answer the rest of the question. So graphing is very important here. Like I said, we will start that today in our lab today. We'll start on that. Go ahead and spend about 5 minutes, read that section, and then we'll talk about the highlights. What kinds of things are in the fork? Large meat grass. The good thing is on my test, but definitely on the AP test, they give you like the line part of the graph. So you want to make sure if they give you all this space to draw a graph, you want to make your tick marks represent something that you're going to fill up most of the space. Does that make sense? We took practice tests last year. And they had like all these tick marks all the way across, right? And then we used like this much of the graph, right? Space it out so that it's going to fill up the graph pretty good. What other things might be important?